We are told a particle P moves with acceleration 4I minus 5j meters per second squared. Okay? At time t equals 0, P is moving with velocity minus 2I plus 2j meters per second. And part A has asked us to find the velocity of P at a time when t equals 2 seconds, and this part is worth 2 marks. Okay? So, because we're given the acceleration, okay, and we have been asked to find the velocity, all right, what we need to do is we need to integrate our acceleration with respect to time to get our velocity, okay? So what this means is that the velocity equals the integral of our acceleration with respect to time, okay? What this means is that v equals, underline the v, the integral of 4I minus 5j with respect to time, okay? We then will get that this is, so 4I with respect to time is 4ti, so it's going to be 4ti, and then minus 5tj, okay, plus c. This is our constant of integration, okay? So, now, what we need to do to find c is we need to use the initial condition, and the initial condition is here. When it says at a time t equals 0, P is moving with velocity of minus 2I plus 2j meters per second, okay, this is the initial condition. So what we can just write here is initial condition, like that. Okay, so what I'm going to say is that I'm going to rewrite quickly our velocity equation, and I'm going to say that our velocity in terms of time equals 4ti minus 5tj plus c. So that means the initial condition is when time is 0, so v0 equals 4 times 0 times I minus 5 times 0 times j plus c, and this equals minus 2I plus 2j. Okay, so minus, which equals, minus 2I, underline the I, plus 2j. Okay, just checking all our vectors are underlined. Yes, okay. Now, 4 times 0 times this cancels, and then minus 5 times 0j cancels. So what we're left with is that c equals minus 2I plus 2j, like that, okay? So what we can say is that our equation for velocity in terms of t is 4ti, okay, minus 5tj, now minus 2I plus 2j, like that, okay? So the next thing I'm going to do, I'm going to plug in and find the velocity when t equals 2 seconds, as we have been asked to find here, okay? So what I'm going to say is that our velocity at a time of 2 equals 4 times 2 times I minus 5 times 2 times j minus 2I plus 2j. This equals 8I minus 10j minus 2I plus 2j. And then finally, this will get us 6I. So we're doing 8I minus 2I. And then we have minus 10j plus 2j, which is minus 8j. Like that. Now we're going to put brackets around this, and we're going to write out our unit, which is meters per second. Okay? So this part is worth 2 marks. Your first mark comes from integrating your acceleration to get a velocity component as we have here. And then your second mark comes from plugging in t equals 2 to get this answer. We have now been told at a time t equals 0, P passes through the origin. Okay, so this is our initial condition. We are then told at a time t equals capital T seconds, where t is greater than 0, the particle P passes through the point A. Okay, we are then told the position vector of A is lambda I minus 4.5j meters, and this is relative to the origin, okay, and that lambda is a constant. We have been asked to find the value of t for 4 marks, okay. So we have been told to look for the position vector. So what we need to do is we need to use the fact that our position vector r equals the integral of our velocity in terms of, with respect to time, sorry, okay? So from here, what we would get is that r equals the integral of 4ti minus 5tj minus 2i plus 2j with respect to time, okay? Just checking all the vectors are underlined correctly. They are. This equals, okay, well, the integral of 4ti with respect to time is 4t squared over 2i, which is 2t squared i. This then minus 5t squared j over 2 minus 2ti plus 2tj plus our constant of integration, okay? From here, what we can do is we can use our initial condition at time equals 0, p passes through the origin. Now that means that the position vector is 0, 0, okay? So what we can say is that, so first of all, I'm going to say is that our position vector, so r, in terms of t, is 2t squared I minus 5t squared over 2j minus 2ti plus 2tj plus c, like this. Let's just fix that plus, make it neater. There we go. This means that at when t equals 0, we get that this is 2 times 0 squared I minus 5 times 0 squared over 2j minus 2 times 0 times I plus 2 times 0 times j, and then plus c equals 0. Okay, so this is 0i plus 0j, and then that just leads to 0 because you're multiplying by 0 all over, okay? This means that this cancels, this cancels, this cancels, and this cancels. So what we are left with is that our constant of integration c equals 0, okay? So from here, what we can just say is that our position vector in terms of t equals 2t squared I minus 5t squared over 2j minus 2ti and then plus 2tj, okay? Yep, all the vectors are in line, that's good, okay? Now, we need to find the value of capital T. And at capital T, as we've been told in this question, the particle passes through point A, which has this position vector, okay? So what this means is that r capital T equals 2 capital T squared I minus 5 capital T squared over 2j minus 2 capital T I plus 2 capital T j, like that. And this will equal lambda I minus 4.5j, okay? Lambda I minus 4.5j. And the reason it does this is because it passes through point A, which has this position vector at time t equals capital T, okay? Now, if we want to solve for t, we need to equate vector components which only have a t in them, okay? So if we were to try and solve it in terms of I, yes, we'd have this t and this t here, but we'd also have this lambda. So what we need to do is we need to equate it in terms of j only, okay? So what I'm going to say is equating j component terms, okay? And what we will say is that minus 5t squared over 2 j plus 2t, sorry, underline the j, plus 2tj equals minus 4.5j, like that, okay? Multiplying both sides by 2, we end up with minus 5t squared j plus 4tj equals minus 9, minus 9j, that's fine. And then from here, what we can say is that this simplifies to minus 5t squared plus 4t plus 9, which equals 0. Okay, so all I've done is bring this minus 9 to the other side and eliminate the j term, okay? Now, if you're to use the quadratic formula, okay, you would need to use the fact that A is -5, B is 4, and C is 9, and you would get two answers. You would get that, in black pen, that T equals 1.8 or T equals -1. Now, T equals -1 is less than 0, and we were told that T has to be greater than 0, so this is invalid. And you would say that, therefore, T equals 1.8, okay? And we only had to find the value of T, so we don't actually need to write the units for this one. So this part is worth 4 marks. Your first mark comes from correctly integrating your velocity and using the initial conditions to get this line. Your second mark comes from attempting to equate the j terms, so this. Your third mark comes from cancelling out your j to get a quadratic, and your fourth mark comes from getting that t equals 1.8. Part C has asked us to hence find the value of lambda for 2 marks, okay? So again, I've taken our position vector equation and plugged in capital T for it. Now, we need to find lambda, and the only component which is lambda is the I component. So what we're going to say is equating I component, like that, okay? What we'll say is that 2t squared I minus 2ti equals lambda I, okay? From here, what we can do is we can cancel all of our i's to get that 2t squared minus 2t equals lambda. And then from here, we can just simply plug in t for 1.8. So we can say 2 times 1.8 squared minus 2 times 1.8 equals lambda. And this means that lambda equals, and then putting this into your calculator, you will get that lambda is 2.88. Okay, so lambda equals 2.88. You get 2 marks for this part. Your first mark comes from equating your I components only, and your second mark comes from getting that lambda equals 2.88. You could have either had it in fractional form, which is 72/25, or you could have had 2.9 as a rounded answer. All of those would have also been correct.